point. Yeah, so audio is always important, but we used to say audio, a video without audio, that's just good for surveillance, right? So and, that mistake is pretty common because when MPEG, the famous MPEG group was conceived and initiated, they forgot about audio, so they still had 1 or 2 meetings without audio, and some pretty smart guy had the idea that audio might be missing for movies, for TV and for radio especially, because that was also on the list. And then MPEG for a long time was called Moving Pictures Experts Group and Associated Audio. So we were always just associated audio. Still, I think audio did pretty well, and when I was asked to present here on 3D audio, I was happy to accept that because it's really one of our major topics. So we have currently 2 major research and development tasks, topics going on. One is about communication for future telephone systems. That's a project we have something like 30 people working on, and on 3D audio it's a similar group. So it's around that size, and that's what we need nowadays to develop some of the new technologies in that area. If you allow me, I will use a few minutes just to introduce Fraunhofer a little bit, because Fraunhofer is a quite unique construction, and it's maybe necessary to understand what I'm saying, because Fraunhofer is this guy here. He was living like 250 years ago roughly, and he had some unique qualities really, because he was at the one side he was a brilliant scientist, so he did some measurements of the solar spectrum, and he was unfortunately 120 years too early to be able to explain it, because he needed quantum theory to explain that, and that was only developed past 1900. But his measurements were so accurate that they served all the physicists later on to devise some of their data from. So he was a really brilliant scientist, but at the same time he was a good engineer, manufacturing all sorts of, developing all sorts of optical instruments. But he didn't stop there. He also founded his own companies, and he manufactured the instruments and sold them successfully. So he was also a successful businessman. So he had all 3 qualities, right? A scientist, engineer, and businessman, and that was the idea behind Fraunhofer. Fraunhofer was initiated to combine those 3 qualities, not just to science, but bring it to application and bring it into the market really. So that's why we are somewhat different from what a university is, but pretty successful. So at this time we are 60 institutes in Germany and more than 18,000 employees. It's probably the largest applied research organization in Europe, and our budget is just American billions, so don't be too afraid. That's not that much for that many people really. The interesting part is all the institutes, they work as profit centers, so if you are not successful, not generating money, we are shut down like a company really. So there have been 2 institutes that actually have been shut down because of not generating a positive outcome. And financing is roughly 1/3 of the budget on average comes from the government. For the other 2/3 we have to make up with whatever we can conceive, so either working for companies, doing contract research, licensing, whatever else. So we have now worldwide operations, so sales offices in almost every part of the world, and increasingly started in the US, but now we are moving more also into Asia. And topics are very diverse, so it's not just signal processing, so or computer or something like that. It's materials, life science, whatever, and production technologies, everything you need in a company. So the original idea was actually to help medium-sized companies developing products they could not afford to develop on their own. That's how we started, and that's why it's so diverse. Myself, I'm now Deputy Director of the Institute for Integrated Circuits. It's now the largest of the Fraunhofer Institutes, of the 60 institutes in Erlangen. They're located close to Nuremberg. And the staff is now more than 800 people this year. And funding is more than 75% of our funding we raise ourselves. So it's only
25% basic funding. We know at the beginning of the year where it comes from. The other components we have to raise ourselves. So I guess I skipped that one. That's now the audio team in Erlangen. We believe it's maybe the largest research group maybe in the world now. We don't know what in China is exactly going on, but it might be one of the really large ones. So we have like 160 engineers and researchers in audio topics, plus a number of students usually. And so there's something about the budget, but that's basically what it takes nowadays to really produce successful new standards. It's very hard to do something alone. So I think what we really try is to combine everything. So we have initiated Audio Labs Erlangen, where we have now positions available for, we have 6 professorships now in Erlangen at the University of Erlangen. It's a cooperation project with the university. So we try to enhance basic research, but we have a lot of engineers and increasingly also people who try to actually sell the stuff worldwide. So I think that's the sort of funny picture. So that's me in the back, in the middle here as a student. And 25 years later, so or 20 years later here. So try to reproduce the picture. So it's so you see how things develop. But the interesting thing is all of the people are still on board. So nobody left. I think we have been quite successful, but nobody was willing to leave really, so obviously everybody was feeling at home. And of course what's named here is our 2 most successful projects. This one is MP3 of course, and the other one is AAC. AAC is maybe not that well known in public because it's just a technical product. MP3 was more like a underground revolutionary product, but AAC was a technical product, but it's in as many devices as MP3 we believe nowadays, so it's another technology. And that's something we have been developing over time. So it was MP3 initially, then AAC, then we have high efficiency AAC MPEG-Surround, extended high efficiency AAC completed 2 years ago. And now we come finally to the topic of today, because 3D is the one thing we want to add here to that list here. So that's the extension of a long line of development we have been doing. But don't worry, I won't just speak about Fraunhofer technologies here. What I want to give you is an overview of what's going on in 3D audio. It's a hot topic currently. Hot topics mean there's not much science sometimes involved, but a lot of marketing and a lot of commercial information and everything else. So what I will try is to give you an overview of what's going on currently, what is proposed, who is doing what, and what the systems do and how they differentiate and so on. And hopefully it's of some use to you. And of course, if you feel like you want to ask questions, feel free to do so. Yeah. So 3D audio, finally, we are there. Let's start to find out what 3D in audio means, right? So it's something different to video. I hope you were all aware of that, but we had what video is now adding with this dimension into the room. We had in audio for 15 years with, it's called in audio, it's called surround sound, right? So, but let's start with the beginning. So that's a scene here. I hope it works, the animation. Yes. So originally we had mono speakers, right? So till the 50s it was a audio transmission meant mono, so you had a point source, some speaker producing something. Then the first big advancement was adding stereo, right? So, but it's, so we call it one dimension, right? So it's just, you have this one dimension of 2 speakers on a line, and sort of improvement. Then the next step that was coming was moving out of the screen, so to speak. If you would attach that to a speaker, that's exactly what video is trying with 3D. Video much later, right? But audio had that, as I said, for more than 20 years. And so if you talk about 3D, so what's left? Going up, right? So and that's of course what 3D audio is about, right? So in adding the height, so adding the height to surround reproduction. But remember this, right? The audio and video are different. I don't want to say that as a businessman, but as a scientist, I have to say, right, to support 3D TV, for that purpose, you don't need anything new. So surround is good enough. But of course, it might be different. I mean, the Japanese, I have seen very big TV screens where they think about having their complete walls as a screen, really. And that changes the situation again, because that means the viewing angles change dramatically, right? So you don't have this narrow angle, but you have something wide, you're sitting much closer, which means height could get some importance really also in TV reproduction. So like having a complete wall of your living room as a TV set, and you see somebody jumping from above, right? So you might want to have the sound from there, or if he's shouting before, or whatever else. So there's some reason to work on this height experience as well, and to me the main reason is really this, probably the new larger displays, they will change the viewing angle we actually perceive, and I think that's, besides effects, which is always nice, right, because you can have some nice height effects, I think these wider angles of viewing, they probably also are a good reason to do something about height reproduction. So now we have one problem when we started out. So there's how to measure the subjective quality, right? So I said everybody's saying we have the best sound audio. It's very strange, because you have all sorts of companies saying all sorts of nonsense things like special wires which should reduce the resistance or capacitance and change the sound dramatically, right? Every electrical engineer can figure it out in a minute that it's total nonsense, but things like that, they are commonplace in audio. And unfortunately, a lot of the things are hard to measure really, so it's not like there's a video guys are a little bit better off, they measure the SNR and have some sort of reasonable correlation to the user experience. In audio, it's very different, so it's user experience and SNR are totally different things. So we can work with so audio guys on the nice sheets, they advertise 100 dB SNR, and I have in my lecture usually a demonstration which shows that 6 dBs are also enough in for a lot of signals. So SNR and perceived quality are something totally different. There are a lot of more factors. Unfortunately, there's nothing to really measure that correctly. There are some measuring methods, some techniques developed for mono sources, for single point sources, like there's the ITU standard PEG, which does some reasonable job, so it gives that there's some correlation with perceived quality. You still cannot rely on what the number says, but if you compare two versions of the same codec, there's some correlation between the numbers and the improvements or non-improvements you have made. But so as I said, for mono there is something, but if you talk about more than mono, there's virtually nothing. So the only thing you're left with is subjective performance evaluation. And when we started with 3D, I was asking what is necessary to give a real boost in user experience. And I was saying, sure, there must be data around which compare mono to stereo and stereo to surround. And there must be, I understand there are no numerical values by some measurement device, but there must be some scientists that have run experiments, try to ask people what they perceive better, right? So surprisingly, there was almost nothing. I was trying to shop around all the world. I was trying to call all the relevant people in that area, and they said, well, interesting questions, but there are really no hard data on what is the difference in sound experience between mono and stereo and surround. And interesting for us, of course, now from surround to 3D, right? So we have tried to do some measurement. There's a paper now from us, I think from last year at IEC, I think it was published. There's some data now in where we have tried to do some measurement. I think in the end you can come up with, if you have the right material, you can come up with a convincing argument that 3D is really enhancing surround as well as that surround is enhancing stereo, but it's not so easy to prove that really. So as I said, I shouldn't be saying that here as a businessman, but as a scientist I think I have to say that. But I think you can definitely do something. So that's the scenario we're in. So we have tried to find out what is necessary to give a good user experience without driving the complexity to the limit. But let's go back a little bit in history here. So what is the difference between stereo and surround? I think the interesting component of surround is we call it breaking. Some other people also call it breaking the stereo window. If you listen to stereo speaker set, you basically listening to something which is behind the speakers, right? So the scenario is always somewhere off, and the surround, at least to some degree, achieves to create more of an impression where you actually are located, right? So if you have a surround movie, so there's something going on around you, right? So it's not just behind the screen, but you have more the feeling of like being in. And surround is nowadays, it was totally different 10 years or 15 years ago, but now it's getting commonplace, it's more common. I just found these US numbers, like 40% of the US households now have true surround systems, not just sound bars or something like that. And the increasing number of cars is equipped with surround, so it's catching on really. Question is, what more can be done really, right? So that already has achieved basically to move the sound out of this window here. So what can be done additionally? So, of course, we can still try to improve the plane. We call it working the plane in the one plane. If you talk about surround, right? So you start with stereo has the problem of the center, right? So you have the two speakers, but you have this phantom center, and this is dramatically improved if you add a third loudspeaker. That's basically how surround started out, and that's how cinema systems work, because the speakers are far apart, so it's an absolute necessity in cinemas really, but also at home. It's stabilizing basically the front, so you can move and the source stays where it is, right? And then you can just add more speakers here. That's the traditional surround setup, and there are others like 7.1 systems are now promoted. But while up to 5.1, everything is nicely standardized, so you can rely material being produced for the ITU recommendation of where the loudspeakers should be placed. For 7.1, it's different, so that's just one possible arrangement. For cinemas, the arrangement is different, and so on. And there are more systems proposed in that direction, like NHK's 22.2 system. They have 10 speakers just in that plane to improve the stability of the image in this one plane. So you basically can move something around in the plane and really have some sort of smooth movement, right? If you have fewer speakers, there are zones where the placement of objects is not so stable, right? So it might just wander somewhere, right? What you really want is a smooth movement of things, and the more speakers you add, the better this impression you can create. But this is working in the plane. With the 10 speakers, you're probably close to optimum. That's proposed. 7 speakers is one thing. But 3D now means going up, right? So, and that's the next step really, 3D. So we are leaving the horizontal plane and add something on top. This idea is not terribly new. There have been a number of people that have been proposing that for a number of years. There's some guys proposing just putting two 5.1 systems stacked one on each other, and you get a 10.2 system. The 0.2 also helps to stabilize the bass experience in the room greatly compared to one subwoofer. Has of course nothing to do with height reproduction, but you have 2 layers of 5 speakers, and that's something that can definitely reproduce 3D. That has been proposed for a number of years, at least 10 I remember. Never caught on because I think there was simply nobody behind who was driving that with a real commercial interest. So it was just, and surround was still out. It was one of the ideas that was maybe just too early. There are simpler systems like 7.1 systems sometimes are abused. If you just redefine 2 of the speakers to be height speakers, you place 2 speakers in the front, above the screen basically, and use the 2 channels in the transmission to just designate them height channels. and you have a very simple system which has some height reproduction, but of course it's limited to sounds just coming from the direction of the screen here. So these were the early days of 3D audio sound, and that's, as I said, that has been around for some time. The things changed when some commercial companies picked things up really. So there's one company that has some success now, that's Auro 3D, and it's basically the 10.2 configuration, the old 10.2 configuration. They have basically 2 layers. There are different configurations, and the most common system is an 11.1 configuration. That's basically 2 5-channel systems, one stacked to the other one. So like I just explained, and they have an additional speaker, which I don't know if they named it that way, but the common term is now voice of God for that one speaker, which is just in the center of the room on top. So that's an 11-channel setup. Technically, it's nothing new really. So it's the old 10.2 system, just with the additional voice of God speaker added really. But the difference is there's some company trying to drive that commercially and trying to convince Hollywood guys to produce movies, or even paying for the sound of the movie soundtracks. And that's how some movies really got produced. So that's something I think which started really commercial interest in 3D audio really. Before it was simply not really an issue. NHK, the Japanese public broadcaster, they went one step further. Maybe somebody is here from NHK? Is there somebody? No.
Tomorrow.
Huh?
Tomorrow.
Anyhow, so basically, it's just an extension of this basic idea. So you take several layers. They just have added a third layer. They have made the layers somewhat more elaborate. So they have like 10 speakers now in this middle, the main layer, which is approximately the height of your ear, of the ear of the listener. There's an upper layer, just like before, but now we have 9 instead of 5 channels in the upper layer. And one of the 9, that's a little bit misleading, because the ninth, there are 8 speakers in the circle, basically on the outside. And the 9th speaker is this voice of God speaker in the middle, but they count it as part of this upper layer. And they have added more speakers in the bottom layer to keep the effort somewhat reasonable, so it's just in the front. Why would you need bottom speakers? Any idea? Huh?
For the mice?
Mice, yeah, of course. Or I think that the main reason usually given is footsteps. Like, so if it's impossible with just the upper planes to reproduce footsteps in a way that people would perceive it to come from down, for people walking around. So you would also always have the footsteps somewhere in the height of your ear. So that's the advantage of having this lower layer. But basically, it's the same concept. So it's just stacking some layers and adding more channels. But for all the systems we have been seeing so far, the common ground is you have speaker signals, right? So you mix something at content production side which is intended to be reproduced by speakers which are at a determined position. So you know basically you have speakers at position A, B, C, D, and so on, and 3 layers and 2 layers, whatever else, and you know where to mix for, and you expect, and the sound engineer expects the speakers to be exactly at the position where he has mixed for. That's maybe true in cinema. At home it's a different animal, because you need to convince a lot of people at home to put the speakers in the ideal place. This is virtually impossible. I think studies have shown it's in less than a few percent of the households the speakers are actually where they should be. So that means they are usually somewhere in the room, but never in the ideal location. And that's the penalty you have with these systems. You basically, to function ideally, you have to rely on the speakers being there where they are. So, but the common thing, as I said, it's channel-based. It's a loudspeaker channel-based. So you produce something that's intended for a loudspeaker channel to be reproduced by a loudspeaker at a specific position. The nice thing about that is the decoder is very simple, because you just need an amplifier basically, right? So you send the signal. You have the signal transmitted somehow by some magic. You just need to send that signal to that one loudspeaker and you're done. So, but it's just a backup slide for that. That's showing just positions of the individual speakers here. So they have some. It's not equally spaced here. There's some reasons to have it like that. You have the center image here. There also commonality with the common surround system. That's why the plane looks differently. And this is the upper layer. That's the lower layer. That's looking at the vertical plane here. You see the vertical placement of the different layers here, including the voice of God up here. You see there's also already quite some science involved to devise the correct speaker positions for things like that. But that's this 22.2 channel system. I would say that's the culmination point of channel-based, loudspeaker position-based transmission systems. And it can be used for 3D by just stacking these layers. However, there are alternative approaches. You can achieve 3D sound in a different way. And one of these methods is pretty old. It was actually devised not too far away from here in Oxford and Reading. So there are some guys here. Sound field description. So basically you do something which is more close, I think, to antenna technology and RF technology. So you just try to describe the sound field. You need to measure the sound field somehow. And at the time, these guys were thinking about that. The technology was limited, so they thought about zero and first order measurement of the sound field and how you see the diagram up there. Basically, it's you have a zero order microphone which is omnidirectional. You record an omnidirectional signal, and then you have 6 microphones placed along the 3 main axes in the room. So you have basically front, back, left, right, and bottom, top. But it's interesting because there was a 3D sound system in the 70s. So the system proposed there that was perfectly capable of reproducing up and down now. So it always included from the very beginning this up and down component. Also, the first reproduction systems that were built, they omitted usually the height speaker because they were busy enough to get the signal processing right for the reproducing the plane. But that's what we call the classic ambisonic system. Ambisonics is just a sort of name that was attached to that. And the nice thing is there are no fixed predefined positions for loudspeakers. The panel, which means you can place loudspeakers somewhere, you have to obey some rules. You cannot all place them in the front, right? So you need somehow get in the right direction, but there you have some liberty. The penalty you have is listed here. Decoders, they must basically do a lot of signal processing because they need to send the right signal to the right loudspeaker, right? So it's not perfectly clear which signal needs to go to what speaker. There's quite some heavy processing really involved in doing that because the simple idea just sending one signal to one loudspeaker doesn't work, so you would get a very narrow sound image, and so there's quite some heavy processing involved, which means the decoder for such ambisonic systems is rather ambitious. At least it was too ambitious in the 70s. The idea, I think, was brilliant and nice, but very hard to implement at that time. You can extend the concept to higher order systems, like our proposals now for second and third order, even third order systems. So, like third order systems would basically have more microphones on the bisecting lines between the main axes. That's to improve the image localization, so you get basically more. The nice thing about all that is you can capture the whole sound field basically from one location. Like I've seen demonstrations, some guys going in a football stadium and place the microphones there and capture the whole ambience with a single microphone. So that's one of the applications that's proposed now. There are some serious companies proposing ambisonics now for 3D audio reproduction. And one of the advantages given is this easy live recording of scenes. So here the guys are named. They're pretty famous. I think Garrison definitely is. For the reproduction, I said that already. You need at least 4 loudspeakers. That's for the planar reproduction. If you want the height as well, you need at least a 5th one. if you want to go down as well, so you need to add something on the bottom as well. I don't think anybody has so far implemented that fully. So this is still sort of a research topic. I know some companies are working on that because there have been MPEG proposals now in that direction, but we haven't seen a full-blown system fully working in that. The complex processing, of course, is one of the reasons why it had limited success so far. You need, as I said before, quite heavy perceptual processing to achieve a sufficiently wide sweet spot to actually reproduce the sound field. It's not just running some signal into loudspeakers. There are numerous problems to solve, really, like higher order systems. There's just no microphones that could record it. So that's a nice proposal. If you create the signals artificially in some computer, you can achieve that. But microphones that have an angle where they are just with like 30, 40 degrees, they just don't exist, right? So the microphones, if you're lucky, you get something which has a nice attenuation out to 120 degrees maybe or so. It gets it gets very expensive if you want to create microphones that have a very narrow angle, and that's something you would need for higher order microphones, really, for higher order sonics, really, to record the signals with this higher order. If you don't do the higher order recording, you have not enough accuracy in your sound field, really, so that, which means if you have objects that basically move somewhere in between the main axis, right, so the localization is not so nice, so you would like to have this higher order system to have a more stable recording of the actual sound field, but there are some physical limitations, for example, there are recording technologies, so that's some of the engineering problems that are usually discussed around ambisonics. As I said, some companies try now with serious resources to actually do that. But the concept itself, I think, is quite brilliant, right? So you capture a nice sound field, and also I think I didn't want to forget to talk about that because it was 3D audio in the 70s, really. So that was already present at that time. Other approaches, something totally different again, is instead of transmitting loudspeaker signals or capturing the sound field, you transmit individual audio objects. It's the MPEG old, failed MPEG-4 BIF's idea. So basically, instead of transmitting a recording of the orchestra, you record every instrument with a single microphone, and have a lot of theoretical problems because you would need to isolate the musicians and so on. But that was the idea, instead of just putting a microphone somewhere and recording the scene, right? You're basically creating a scene out of individual objects, and instead of transmitting one signal, you transmit individual object signals. The objects itself, they can be, the complexity of these objects, you can think about quite different levels of complexity. So you can have simple scenarios, probably a mono object, omnidirectional radiation, and you put it in some location somewhere. So we have the coordinates where the object is radiating from. That's the most simple scenario, but you can think about much more complex things, right? If you want, you can add a width or height to the object. You can give the object some sort of spatial extension. Not just a point source, but you want to describe an object which has some sort of size. Think of a drum set, for example, which is 2 meters wide, 2 meters high, and including the drummer, maybe 1.50 meters in depth. So, and you want to describe that, really, you want to put a drum set somewhere, right? And which means this one object itself is pretty complex, right? Because you also want to make the localization of the individual pieces of the drum set correct. So, which makes it really complicated. And if you want to add more complications, so you can add some reflection parameters to that object because you move something in, right, which is probably reflecting and therefore influencing other objects. So arbitrarily complex scenarios possible, and that was one of the reasons why MPEG-2 failed, because they have tried to implement all of that, right? So it's probably beyond the capabilities of human brains to conceive such systems fully. I think we need more machine power to finally come up with something. having said that, I think one of the interesting questions I heard recently is how far are we actually from listening to something and thinking we are actually in the real world but not listening to something? And what do you think? Is there any sound reproduction system where you would walk into and say, I can't, with eyes closed, I can't say whether this is transmitted or whether this is the real thing, right? So I think we are still very far away from that, and some of the reasons being given here is all of that reflections and radiation from different sources and how that behaves. It's totally out of control currently. So if somebody says beyond 3D there's nothing to be left, nothing left to be done in audio research, it's definitely wrong. There's a lot left still, but 3D is the next target. So, but back to the objects. So you can, as I said, you can have these objects arbitrarily complex. The nice thing is, again, you don't have predefined loudspeaker locations. In theory, you could put your loudspeakers in your living room somewhere, right? You need to put some reason to it, and not, as I said, not put them all in one row in the front, but you need to distribute them somehow in the room. But based on that, you should be able to reproduce the objects in the right place with a lot of clever signal processing. And that's, again, the downside of that approach, right? With the loudspeaker-based systems, the systems we have seen in the beginning, the decoder is simple. You just connect the amplifier to your output. Here, you need to do all sort of complex processing to devise the right signal that is played back from a specific loudspeaker. In the end, you need loudspeakers here as well, right, to reproduce something. That's, of course, clear. This is a picture of MPEG-4 times, just to show how complex things can get if you do this object-based representation. You need a lot of things, right? You need to describe the objects. That's the MPEG-4 way how to do that. You could do it differently, of course. Then you have a scene description, which describes the relation of the various objects. Of course, that's dynamic, right? So it's usually you're not looking at a still picture, but something that's changing quite rapidly, which means you need to update all that, right? And then you have the object content itself, like a movie, a flick of a movie or something like that, or a small sound sample, and so all that needs to be transmitted, needs to be composed, rendered, sent to the reproduction devices in the end. That's a very complex task. And I mean, maybe the closest to that is nowadays in game engines. So there are some pretty complex audio game engines where they have sound objects with some of the properties based. Somebody's nodding here, right? So this may be the closest you can find nowadays. But they don't have to worry about transmission, about content production on different sites. So it's like more close, it's easier to do. But that's something I think we should take a closer look, maybe to learn from, or maybe to also do something on that end. That's definitely a very interesting area to work on. So that's to scare you a little bit about object-based audio, but that's not really the intention, because I think you just need to find the right mix of complexity and not. Dolby is trying that right now with the Atmos system. You have probably heard about the Atmos because they are spending so many hundreds of millions in marketing that system. So we're not talking about 7, not 8, I'm talking about 9-digit numbers. Establishing such a format, really. Colors are not nice, I hope you can see. So, as I said, it's basically trying to get some object-based approach into audio, but they try to do it clever and in not too, how do you say in English, not to disrupt too much of the existing ecosystem at the same time. So it's somehow, that's the classical cinema setup. You have the front speakers, usually hidden behind the screen. You have some speakers on the side, usually arrays because the room is too long for a single side speaker, and there are 2 arrays of speakers in the back. Arrays is just because cinemas are much larger, so you distribute the single source. But basically what's transmitted is a 7.1 signal. Or can also use it for 5.1 signal. You just need to combine some signals. And that's basically kept as far as we understand what Atmos is proposing. That's the basic arrangement is basically kept. There are some additional speakers added. There are some more speakers in the front behind the screen. I think that's As I said before, it's one of the important things really to get a stable image from the screen, independent of where you sit and how you move your head and so. And then there are some more subwoofers added, and there are additional surround speakers. That's this one is that little thing, one and then the purple. What's the right English color? Violet, right? Violet ones, right? And then you have these ones, but the main addition is really these loudspeaker, let's say, arrays on top. You put a lot more loudspeakers on top, and that's why they call it 3D, right? Because these loudspeakers. So all the other additions are just to improve the image in the plane, right? Similar to like what NHK is proposing with the 10 instead of 5 in the plane. We're adding more to the plane, and then but the real difference to have that capability to have something not just in the one plane, but something coming from the top. And the content that's played in there, so I think as far as we understand that, or what's published so far, is there's capability to send objects and loudspeaker signals. So basically, it's a transport system, and it depends on what content you run into it, right? So probably it can be used to gradually add more object content. How complicated the objects are, I think, will depend on how complex the processing is available. It's similar. If you have a lot of processing power available, you can do more. If you don't have that, you are limited to probably a number of objects you can do and so on. The parameters, of course, are not known because it's a proprietary system. So that's some of the company secrets, I would say, as long as they don't publish that. But as I said, it's one idea to get this object-based idea into public service, into how to call that, into commercial applications. I think is the right word here. Besides that, if you want to call that hybrid system, MPEG is also working on 3D audio, and I would call that even more so a hybrid system, because let's start with the first bullet item. So standardization process is initiated. There were submissions due last Friday. Last Friday were submissions due. There were 7 submissions, 7 companies to propose a system. And there are currently ongoing listening tests now, and in July results will be available, and based on the results, a system will be selected as the baseline for further development of the MPEG standard. So that's what's outlined here. A first version for speaker-based systems is supposed to be ready end of next year. So it's not that far out really. So there are a lot of components in. The basic ingredients are, for once, it shall be able to transport and render loudspeaker-based signals. So in other words, it has to be able to accommodate 22.2 channel signals from HK, 7.1 classic, 5.1 classic signals, or 11.1 from audio 3D signals, or whatever else, so whatever loudspeaker configuration you want. And there's an explicit requirement for off-position rendering, which means there should be some compensation for speakers not being placed in the ideal location really. Besides this classic channel-based system, there is a capability to render a number of simple objects in the speakers, in these speakers, so you can basically add. You can just have objects, but you can also combine it with conventional loudspeaker signals. And the third component is an optional component, is for the transport and rendering of higher order ambisonic signals, and that will be one of the interesting exercises there to compete the results of what ambisonics reproduces and what the other approaches are capable to reproduce. So it's will be one interesting also from a scientific point of view, because there will be a serious comparison of different approaches, and we will see where we get there. But idea is to have some components standard. The more easier ones, the more clearly visible components, to have them standardized pretty soon, to be out there next year. And some of the more elaborate will be developed over time, but of course the system will be, the idea is to keep the system expandable or in that sense. for the transport of these signals, I mean, there's always two things, right? Once you need a format to produce the content in, or you have the content to store the content in. The second thing is you have to transport them from A to B. For that, the system basically can do all the systems that are out there. So there's a list, not necessarily full list, but all the systems that are currently somewhere in use or conceived can be accommodated in that. So you see all these. From the codec point of view, so for the codec, the codec to transport that will build on the existing MPEG system. This MPEG audio system has become pretty large. So you have now a long line of MPEG codecs. MP3 was the ancestor of all the modern MPEG codecs, I would say. And AEC in different flavors, it was always added some component which is given in yellow out there. And you see at the end of the line 2014 there's MPEG-3D, so which means there's the transmission technology will most likely, unless there's a significant advantage in doing something differently, but the idea is to build on the existing system, not to render the existing 6 billion installed AEC devices useless, but try to reuse as much of that transmission capability, just add the components that are necessary to create the 3D add-ons really. So the basic components are as much of that, the requirement should be carried over from existing MPEG systems to build up this stable installed base of so many devices really. So that's overview of what is currently in the oven. That's all very nice in a nice listening room. That's, for example, a picture of our main listening room. So you see the number of loudspeakers here, right? And a lot of them, I guess 100 or so. And that's a picture of just a graphic picture, because usually the speakers are hidden of the Dolby Atmos ceiling speaker arrangement, but I think anybody trying to put that into the living room would have a hard time, right? So this is not an easy task, I would say, mechanically and also maybe socially. So that's which means something else needs to be worked on. That's the one missing ingredient here. So I think for cinemas there's a solution. For the home, there's nothing public yet. So the MPEG process requires some capabilities in that direction. So we will see something that's not yet public information. We will see more in July when the winning solution has to be made public. Dolby hasn't published anything yet how they think to put it in the living room, but everybody's waiting for them to also put something out, how to do it. But whatever it is, the number of loudspeakers that's required needs to be reduced, right? And so serious downmix capabilities, matrixing capabilities, a lot of things are discussed, and that's, if I recall how many people in our team are working on that, it's quite a number just in that problem, how to devise lower number or lower order signals out of the full-blown big signal really, and it's not an easy task really. So there have been some bad experiences in MPEG with matrixing of such signals, and so quite some experience in that area. That's my eyes, it's the most complicated of all these tasks that I had in that role really, how to go from high resolution big systems to smaller ones without sacrificing too much. So that's one of the really demanding tasks. But there's hope. You can go in the cinema, or you just go in your car, right? Because a car is a nice 3D environment. And so that in a car you have a lot of speakers. I think, I don't know, but even cheap cars, they come with at least more than 5 speakers. Expensive cars sometimes have up to, I don't know what the record is, but I guess 40 speakers is definitely not a high number. So there are a lot of speakers in these cars, and there's also a lot of voodoo in these cars. Each car company, as far as we learned, they have their own voodoo magician, pronounce it, who comes up with the correct sound and does all the magic that's required to get most user experience out, and all of them demand more loudspeakers. Of course, the manufacturing process demands lower number of loudspeakers. And anyhow, but car is something you can put something in the ceiling, right? Because you have a ceiling, you can put something. There's anyhow some loudspeakers somewhere in the bottom because there's some just end up there because of the design. So you have a lot of loudspeakers you can work with. And you see, that's the one dimension. That's the old stereo system. I think we're at least there. There's some back and forth rendering, usually with some upmixing capability. And of course, the height component is something that's not exploited yet, but there's something, for example, we have been demonstrating with Audi, the car company Audi, at a computer electronics show in Las Vegas this year. We had a nice development car which was showing 3D audio in the car. It was quite nicely received, and so we expect that some cars will be out there in 2014 with 3D sound in car. And there's a picture below which shows, for example, where the speakers could be placed to, right? So that's, how do you call it in English, you know, the things there are on the side of the windscreen and... AB?
Yeah, AB, beam.
Beam. So you place them in the beam, so that's one of the options where you can put the speakers to, right? And so you require quite some complex processing to accommodate for that. The speaker positions are not ideal, but you have a lot of speakers in different directions, which is definitely helping. And so then the trick is to actually have the processing that's required to create the right image from the speakers not being ideal position. But of course you need to do that for every car differently. So quite some effort, but on the other hand, there are a lot of cars sold every year, and most of the radios sold are attached to the car, right? So there are hardly any radios sold separately anymore. So it's usually a car attached to a radio. So that's
the processing will have to be done real time.
Yeah.
You'd have one CD, and the processing would be done at the.
You have to do that.
Player.
Yeah. But on the other hand, processing power is getting cheaper and cheaper, right? So that's the one thing I'm least worried about. I think our guys are more worried about a requirement for an additional loudspeaker somewhere than for another 10 MIPS somewhere. That's 10 MIPS will be gone in half a year, right? Because the next generation of in car it takes a little bit longer, but they are more conservative replacing the hardware. But usually that if you require processing power, that's something that's available in quite huge quantities, and that's the one point where time really works for you, right? So that's inevitable that in 5 years you will have so much more power again, and so we don't limit ourselves in development nowadays anymore too much by thinking about that. So this is the one resource that's cheap, right? So cars are a nice thing, but there's a even more attractive target, of course, the 3D. Cinemas, how many cinemas are in the world? Like, I don't know, a couple of 10,000 maybe, but how many mobile phones are in the world? It's, I think annual production is close to 1 billion devices now. And I heard numbers from Korea that the mobile phones are replaced every 11 months on average there. This is a fast thing, so definitely something to be thought about is the mobile 3D. What to do in the mobile space? Of course, you are limited in number of speakers you can place on a mobile phone. And you can place a lot of speakers, but they will be small, and it shouldn't help that much, right? Because you want to have them spaced apart as far as possible. But that's how things are. And the other target, of course, tablet PCs. They're a little bit nicer because the devices tend to be larger. Also, the difference is sort of disappearing because phones now get really large, not that much smaller than tablets anymore. But having said that, I think there are ways to do that. Basically, there are two ways to bring surround or also 3D to mobile devices. One is, of course, binaural headphone technology. That's also part of the MPEG submission process. So we have developed a 3D rendering on headphones, these head-related transfer functions, where you basically, human beings, they just use their 2 ears to determine whether it's coming from here. Difficult sometimes, but at least the 2 ears are sufficient to also determine whether it's coming from above or not, right? So you can try to model that and process the signals in a way that you can actually create an image of being above, also in headphone signals, and that's something which we have found works surprisingly well. So we have been working on that for quite some time. So that will be part of the MPEG process, also working on headphone rendering of 3D audio signals. So and of course specifically has mobile phone usage in mind. If you talk about loudspeaker reproduction, it's more difficult because there are some physical limits, dimension of the devices itself, how far the loudspeakers are apart, how many you can actually put there, what are the characteristics. They are usually pretty bad, the loudspeakers on mobile phones. So there are a lot more limitations, but with some meritor processing, the better ones, nowadays they are based on sort of semantic audio processing, which means it's not just an equalizer anymore, right? So there are a lot of small companies now that sell a lot of stuff, but if you look into it, it's basically an equalizer. So they do some sort of frequency reshaping, right? But the more sophisticated ones, we call that semantic audio processing, which means we try to get hold of a lot of more components in the audio signal, try to separate different components and process the different components separately. It's very different to just doing equalization. And with things like that, a lot more can be achieved really than just increasing the number of high frequencies or adding more harmonics to the signal. So you can do something, but at least for surround, I think we have a nice solution. We have demoed that currently, it's going to be going into product soon. And so for surround, you can create a nice image. You have a tablet, and if you're in front of the tablet, there's some limitations, as always in life. But you can have a nice out of the tablet sound, just 2 tablet speakers. That's something we are demonstrating now for almost a year, and it's ready for products now, and we also implement it. So this is some capability. It's not yet 3D, but there's principal low limitation. You can also have that in 3D. So that's mobile devices. I have a tablet with me. I couldn't try it because I just got it yesterday from one of my people. But if someone is interested, I could give you some demonstration of what a tablet can do really to sound nowadays. So, and the other thing is, of course, as I said before, mobile phones get larger, so and which gives you some more capabilities. That's just the binaural headphone technology. It's, I think if you're interested, read the appropriate papers. I think we saved that here. So the trick is these head-related transfer functions. You basically model the head. It's not that easy because heads are different, hair is different, ears are different, and so you might need to accommodate or to adapt to specific ears or head shapes and so. But basically, the technology is working, and that has been demonstrated. And as I said before, it's part of the MPEG 3D process to also standardize a 3D headphone rendering capability. Now, something different but related to 3D audio. That's an experiment we have been showing with the BBC in Wimbledon in 2011, 2 years ago. So there was a speaker application you could download from some, I believe, BBC website, and the idea was to adapt the signal more to the needs of the different needs of different viewers. And Wimbledon was chosen because there were a lot of complaints. Some people want more of the crowd, other people want more of the player, right? Some people get annoyed by the noises the player generate when they hit the ball, and so some religious people say that's even not appropriate to transmit those signals. So, but you can't get it right for everybody, right? So the idea was, can we do something to accommodate different needs, really? And that's one of the interesting projects, also part of MPEG 3D process, is to actually allow the manipulation of sound objects. If you have objects in the signal, you can also manipulate them differently. And for example, in that object, it was rather simple experiment. There were basically two objects. One was the commentator, no, three objects: the commentator, the crowd, and the microphone, which was directed to the players on the playground. And so there was a slider, and you could basically slide back and forth and determine on your own what you want to listen to. Should I give a demonstration, or do we want to do that later? Yeah.
That'd be fun.
And the interesting component is that's even backward compatible, so you can add that to the current system. So the BBC is broadcasting in AEC, fortunately, in the UK here, and so you could add that to existing receivers. Existing receivers would just get the average level out, but if you would have an advanced receiver with a new capability in, so it could extract this extra information and use it to manipulate the audio objects in the scene. So let's hope for the best. I tried it before. We have sound, right? Can you turn it up a little bit?
Plays a forehand, they're now training ground shots. Songa's going to come into the net again. Takes that off his knees, it just falls in, he's going to get past. No, he's there! With a dive running, and still the ball's in place. And Songa.
So that's the regular mix, and now I use the slider to either go to more of the crowd or more of the computer.
Djokovic crouches down low. He has his feet very wide apart to receive serve, and it's working for him. He plays a backhand drop shot now from Djokovic. Songa's racing after it, gets to it, plops it up. Now the attempted lob not high enough. Backhand overhead from Songa, who's now back at the baseline. Plays a forehand. They're now trading ground shots. Songa's going to come into the net again. Takes that off his knees. It just falls in. He's going to get past. No, he's there with a dive running, and still the ball's in play. And Songa just stretched out, and Djokovic turns to the
More of the
ground
commentator now, right? So
touches them as if they are his lying absolutely flat on his back, and now
she's still talking, but it's almost gone. So that if you don't like the commentator, you just move it at that. You can adjust how much of attenuation and you want to do, but that's one of the capabilities which I think are very useful in future systems. It's also for the hard of hearing people, and so you can just remove some of the background and have more of the dialogue and things like that. So this is some of the capabilities MPEG-3D will also be able to do, and that's some of the technology components that have been demonstrated here in that experiment.
Just a little bit like MPEG-4 bits somehow coming to life.
The difference is that actually it's not a MPEG-4 systems transport channel. It's all hidden in the audio stream, so it's basically hidden below the regular audio stream. So you don't need to change routing in a studio or so. That's just the same signal. And as I said, backwards compatible to existing installations. You would not break existing systems if you would add that capability. So, that doesn't want to go. Sorry. Breakdown here. Okay, that's just a picture that explains how it's working. So it's basically you have an object encoder of individual sound objects, right? And you hide them in the default mix. You have a default mix which is talking to the regular receivers, and you add some additional parameters in the decoder. You can extract the audio objects and manipulate them separately. or you could also send them somewhat differently. So that's that capability. And to finish my talk, I want to just bring in another idea, which is conferencing really. We would think about 3D audio and conferencing, but that's some project we have been carrying out. There was one of the early phases was some European community-funded project. British Telecom was involved, so it's a British component in. And the idea was to increase the, we called it at that time, togetherness of people, right? So like, idea was to create 2 rooms located very far apart, but if people would be in the room, they would have the feeling like they would be in the same room. That was basically the idea. So there was a test run in Sweden, for example, where some households were equipped with a device for free, of course, initially. In the end, they were asked if they would like to keep them, and a large number said yes. So basically, it was intended for families living apart. So you had 2 rooms. It was on all the time, right? So like people would just go in that corner and would know that that would be transmitted to India. I don't know where. Some remote place. India is on the edge because light speed is there already a limitation for works. There are some limitations already, at least for making music together. That's another experiment we tried, for example. But you would have rooms in each house, right? And you could move in there and just look, is there somebody there on the other side, right? At that time it was just surround, but 3D would really enhance that feeling of being really in the room together. And we have, for example, there were some game scenarios. What you see here, 2 tables. You could play games. So the like board games were converted into computer games, but you have 2 boards on both sides. You could play chess together or whatever else. And the idea was that people would feel like sitting on the same chessboard. So that was the experiment, and that worked pretty nicely. And audio. Why is it not working? Yeah. So as a test people, we have been using real families. A lot of our families, so people were asked to bring their families in, and they, in Sweden it was just some households that volunteered to participate in that experiment. And not so easy to find the correct test setup. So we were experimenting quite a bit, but for example, this test I'm reporting here, there were 25 people, and children did not vote directly, but something is quite clear. So I wouldn't say that's a scientific result here, right, based on the small sample. But what I want to show is here, did it feel like you would be in the same room, right? And we tested that with a audio setup that just had a mono speaker with a telephone transmission quality, and compared that to a surround system with a hi-fi quality. At least for the few samples we took here, so the difference was pretty big, and people saying it felt like being in the same room or not, right? So in other words, so I think there's also communication is a big open space. We are still using telephone technology with a sound quality that's not better than in 1900, right? So, and a lot could be done here, and this is some indication that there's a lot of things that can be improved, really, right? And that's some of the components we are also working on. So I think you'll also see that in that environment, and that's it. So that's it.
It's very impressive. Thank you very much for such a great overview of all what's going on in audio, and it's clarified many issues that I had fused in my mind, now much clearer. But perhaps we should take some questions from the audience. Andy?
Yeah, you in the middle of your presentation you mentioned 3D audio ideas coming into cars. Do you have something built into the standard to send compression metadata? When I'm listening in a car, I think I might want the sound compressed.
Compression, you mean now dynamic range compression?
Dynamic range, yeah.
That's actually it's a standard technology, so that Dolby had it in for a number of years. AEC has it in since the very early days. So, and it's for example in the UK, BBC uses these data as far as I know. So it's on air. It's the new Dash streaming format has dynamic range compression data. So that's basically a standard technology. It's not without problems. The systems which are out there at this time, they have some limitations. They work most of the time quite nicely, but neither system that's out there is perfect, I would say, at that time. That's one of the interesting topics, and it's one of the areas where proposals are received at MPEG to add some of these components, some more advanced stuff. For example, at the last meeting, there was a proposal by Apple to do something about more finer time structure in updating these metadata for dynamic range compression. That's one of the problems that's left. And so that there's definitely going work on in that area, and I would expect that the codec will include something like that.
So you think we can improve, we will have it and improve it?
Yeah. And important for all of that is to get really as much feedback as possible of. So it's broadcasters unfortunately don't send too many members anymore to MPEG. So it's our task nowadays to go back and forth and present the ideas to the people that would actually use it in the end, right? So, and it looks easy. It's not that easy, and that there are a lot more problems in that area. If you're interested, for example, one of the big issues is this. I mean, the music industry is going crazy. Had gone crazy many years ago with all this loudness war, right? So you have virtually no dynamic range left in many issues. Still, they want it even louder, right? What you get is distortion, because then you hit the upper limit of what your D2A can hit, and then you end up with mitigating technologies to try to limit the effects of what these guys are doing with their content production. But of course they blame it on MP3 and then the others to destroy the sound. Yeah? But I would say the MP3 is way better, for example, than the majority of produced material, well, at least this mass-produced material, where we have where we spend quite some effort to mitigate the effects of this not existing dynamic range and very loud signals. So I hope that
Thanks. Yes, that's awesome.
I'm certainly very encouraged because my daughter is living in China, and we're using Skype to keep in. She's working in China, and we're using Skype to keep in touch with her. And if we have a technology that's allowing us to be feel that she's a little bit more closer to home, that will certainly sort of help with our loss of her presence. Thank you very much again, Bernhard, and please join me in showing our appreciation of this presentation. We'd like to a small gift token of our appreciation. So you find it all at Brunel, and
thanks a lot. It was a real pleasure to be here. And, I think the topic is at least I find it interesting. So
yes, we really appreciated this presentation.